Okay, here is another session on simultaneous equation solving. And this one reads, which of the ordered pairs of numbers C, D satisfies the simultaneous equations shown? And here are the two equations. And here are 5 pairs of numbers. So this is a little different from the other one. In order to answer this, you'd have to have a value for C and D. So it's like the other one, solve both of them, as it were. Not just to solve for C or solve for D. You're really going to have to get them both. So now go ahead and pause it and then see how you'd make out. Okay? Then I'll do my answer. Okay, on this one, I'll just do whichever one seems easier. There's already a built-in negative sign. I see that I can cancel the C's here. If I multiply the first one by 3, that's not so bad, so I'll just do that. That cancels out. 3 times 2 is 6. Well, that cancels out too, which is a little unusual, because that gives 0 on this side. And on the other side, I get 18. And that's also 0. So basically, this is now, like you might say, a trick question, because you can't solve for C or D. Basically, the second equation is a multiple of the first equation. And because of that, it really isn't a single value for C and D. There's a relationship between C and D. In other words, this is really only just one equation here. The second equation provides no new information because it's just a multiple of the first equation. Now, we didn't talk about that before, so it's kind of like a trick, but we're reviewing it now, so you'll learn about it. So you really just have this one equation, and you want to know which of this pair of numbers will satisfy this equation. Well, the simplest way of doing this was probably just checking each of these numbers. C plus 2D. You could solve for C, but then you're still going to end up having to plug it in to see which one satisfies it. I would just go through them. I wouldn't necessarily go through them in the first order because they might be tricking you. Let's try it in the reverse order. So these are C, D, and that we know that because they told us that. C plus 2D equals 6. So C down here would be 3 minus 2 times 9. Does that equal 6? Well, that's 3 minus 18. That's not going to equal 6, so that's not it. The second one is 2 minus 2 times 1. Is that going to equal 6? No, that's equal to 0. The third one is going to be 0 plus 2 times 2. That's not going to equal 6, so that's not it. So basically we get no, no, no. Next one is minus 1 plus 2 times minus 3. Is that going to equal 6? See how I put a question mark over the equal sign? I don't want to say that it's equal to that. I want to determine that. Whenever I write an equation, I don't want the equation to be a lie. It's like when you write a sentence, you don't want it to be a lie. You want it to be, each equation represents a complete thought, like a sentence does. And each equation, you don't want to write an equation that's simply not correct. That's not going to help you. Okay. This one is -1, this is -6. That's not equal to 6 either. So it looks like, it turns out A is going to be the answer in this case. Maybe we should have started with A. -2 plus 2 times 4 is equal to 6. And that's in fact correct, because 2 plus -2 plus 8 is equal to 6. So the answer was A. So I took a little bit longer on that because I thought they were going to make the last one, but it didn't work out that way. But still, you get up to 2 minutes on some problems.